amalgam and corrosion, and replace, and what is the better replacement for it, and about the type of glass ionomer, their use and differences, the reaction of dental cement if it is exposed with radioactive materials. Okay, I think this is all that you already asked in the Borang B. Yeah. So in this scenario 1, for the basic dental sciences, the learning issue is about of materials, properties of materials, dental amalgam, and dental cement. Yeah, this is the learning issues that you need to know. Yeah, I think it's the same as you. Yeah, it's about the definition of material science and engineering and dental material science. Slides, yeah, from all the focus group, and I think you already covered all of this one. Yeah, so in this presentation, if you have something to ask, then you can ask me. I will directly answer your question if I can, but if not, I will find it out and I will let you later. Okay. So second one is microstructure, processing, and performance in material science, and the classification of group of materials. Yeah. This of dental materials. This is very important because you will use these materials, but in using these materials, you have to know about their properties. Yeah? And then we will cover the dental amalgam and dental cement. So, about the definition of the material science and engineering. So this is an interdisciplinary with inventing new materials and improving previously known materials by developing a deep understanding of the microstructure, composition, synthesis, processing, and performance relationship. Yeah. So usually, because there is engineering here, usually the goal is, the target is to have to develop some kind of new material that we will need in this world. Okay. After underlying relationship between the synthesis, processing, structure, and the properties of materials. Okay, so it will cover a lot of materials that we are using, especially in engineering and dental materials, or any materials that we use, especially maybe in the industry, airspace, and everything. Yeah. And materials engineering, the focus is on how to form the materials into useful devices or structures. Okay. So it is the technology on how to make or transfer the material into useful devices. Yeah. So the group of materials that we have in this world, yeah, is usually only four: polymers, ceramics, and composite. Yeah. In engineering, you have sometimes they put some yeah, and other material that is very important for the engineering. Yeah, but for dental materials, we use these four groups of materials. Okay, remember metal, polymer, ceramic, and composite. Okay. This is the fundamental. We talk about material science and engineering. So we have this pyramid, yeah, about which is this, yeah, between the structure, yeah, here. You can see this?
Yes, Prof.
Yeah. Okay. Which is the description of the arrangements of atoms of all the materials that, and then also there is the properties. Yeah, the properties is it means the material properties is maybe the about the strength, the elasticity, the hardness, yeah, of the materials. And then we have the processing here. How to make this our shape into useful component, and sometimes it will cause changes in the if you give too much heat or lower heat or maybe hammering, and the properties will change. Yeah, and it depends on also on the groups of the materials. And then inside here, which connect the one that is right here, it's connecting into these structures, performance, and this is the composition or the characterization of the materials. Yeah, so the characterization, how we know about this material and the character of this material, and we have to know the character. We have to test these materials. Yeah, how is their strength, how are their hardness, and etc. Yeah, and the composition, it also involves the composition of a material. Maybe they will have some chemical reaction or physical or mechanical reactions, yeah, to make up our. And the last one is the performance. We have to know about when we all process the materials, yeah, with the properties, structure, and characteristic, and we have to know what their performance. Yeah, is it good or bad, and what is the cost of the fabrications, and is it worth it with the form or the performance is good or not. Yeah, so this is the fundamentals of and all the relationship between the structure, composition, properties, processing, and the performance. Okay, any questions from here?
No, Prof.
No questions? Okay, let's move on. Okay. science. Yeah. So you are students in dentistry. So you will face all during about dental materials. Yeah, you are not going to avoid this because even in the clinic, you will use all the dental materials for the treatment of patient. Okay, so dental material science cover manipulation. Manipulation, it means the mixing, but in dentistry we it's not a negative terminology, yeah, but in dentistry, like we call it a manipulation. And also the care and evaluation of materials used in the treatment and prevention of dental diseases with tissue of the face and mouth. Yeah. So we will cover the cell itself, but also we know that our treatment in dentistry includes preventions of dental disease, which also use some dental materials. And also we have to know about the interaction of these materials to the tissue or in the mouth. Okay? So it also includes physics and biology. But as you know that dentistry for delivering optimal health care and delivery of minimally invasive dentistry, then we know that there's a lot of development in the dental materials science and also materials itself, and it's also changing rapidly because of the development of technology and in dentistry. Yeah. Okay. Here's the human tooth. You know that the human tooth have a composition of enamel, dentin. There is also the pulp, yeah, and cement in the root, and also they have connection with periodontal tissue. Okay, all of these, we in dentistry, we do the treatment in the human tooth, especially in the environment of in the mouth. All for this treatment, there will be oral environment. There will be materials in the dental lab, also in the clinic, of course. And as you know, the dental materials, we usually use the preventive materials, the restorative materials, and the auxiliary materials, yeah, for the lab and the clinic. Yeah. So these two, preventive is if there is no disease or there is no maintain the cleanliness of our teeth and mouth, yeah. So there is some, yes, yeah. But if there is a disease and there is a caries, then we have to restore this tooth, yeah, this teeth, and we also materials. For the auxiliary materials is the materials that we use everything to of these preventive treatment, restorative treatment, or rehabilitative treatments. Yeah, like in prosthodontic, in orthodontic. Yeah, we have all of the material that we use to treat the condition of a patient. Yeah. Can you see the arrow?
Yes.
Hello? Can you see the
Yes,
arrow?
Prof.
Yeah. Bonding agent that we usually bond composite resin to tooth. Yeah. As you see, we do the cavity, the caries, and then do the restoration. Yes, with composite resin or with this. And also this one is for preventive materials. Yeah, for preventive, because of the fissures of your teeth, then we cover it with a resin-based sealants, yeah, or with glass ionomer. This fissure is protected with resin or fluoride, so that it will not cause caries. Okay? Understand? Please let me know if you don't understand, then you can just ask me. Okay?
Okay.
Yes, Prof.
Okay, Prof.
Okay, this is the, yes? So,
No one asking.
Okay, this is the structure of a material. I just put some pictures so that you can see. Yeah. So there is the subatomic level, yeah, like this. And then we have the atomic level, the arrangement of atoms in materials, yeah, something like it, bigger. And then the microstructures, microscopic structure or microstructures. Yeah, this is the pictures. This is the arrangement by electron microscopy. Okay, so if you have a metal, if you push it and then you look in the microscopy, then you will see this kind of pictures. And then after microscopic, you have the macroscopic structure, which you can see it or you can view it with the naked eye, yeah, visually, something like this. Your teeth maybe, yeah, you can. If you look inside, this is the microscopic structure. This is the atomic level. This is the subatomic level. Okay? Okay, then this is the classification of materials based on the structure. Yeah, we have something, the arrangements of atoms that we call crystalline, and there is the structure or the arrangement of amorpho. We also have a single crystal, polycrystalline, and grain boundaries. Yeah, crystalline is the arrangement is very in order. Yeah, like this. You know, this is the atoms is very in order situation. Yeah, each of these atoms will connect with others atoms, so they are very close in contact and very strong bond between the atoms. Yeah, and the amorphous they are not very in ordered arrangement. you see, not so ordered like this crystalline. So you can see that all the atoms is not very well bonded between each other. That's why the amorphous one is that crystalline. Yeah. So if you give heat to the they will melt. If we give heat, yeah, they will melt, but need high energy of heat. But the amorphous is not, because of their bonding is not fair. So if we give heat, then it will melt, yeah, lower temperature, in lower temperature, yeah, in contrast with the crystalline. Yeah, so crystalline is usually the structure of metals. Amorphous is usually the structures of polymers. Okay, got it? Okay. Okay. So, yeah, single crystal is we have all of this one crystalline. Yeah, the same and only one crystal. I mean, not one atom. I mean, but it's the same. Let's call it. Yeah. The same arrangement. And polycrystalline means that like this. Yeah, you have arrangement of crystalline here, and this one also, and this one. Together, the arrangement is different, but each single crystalline is there with the same order. Okay. And what is the grain boundaries? Grain boundaries is what's got. This is a crystal structure. You have the cubic. You have the body-centered cubic crystal, face-centered, and hexagonal. Yeah, all of these will have the different properties in. Okay, I think you already got this from high school, right? What is grain boundaries? This one. This one is a polycrystalline. Yeah, you have this, the arrangement of crystalline here also, and this one. And in the border or the barrier between this arrangement and this, there is like this. Yeah, this is the barrier, and this one is called the grain boundaries. Yeah, and some heat, these materials like this, well, the one that will be is the grain boundary. Yeah, this one. These arrangements of the crystalline is quite strong. This is quite strong. All of this is quite strong, but the boundaries, as you know, the bonds between all of these arrangements is not you can see. So if there is hammering, a trauma, or a heat, usually the one that will change first or will be affected first is this grain boundary. Okay? Okay, next. Now, these characteristics are based on their structures, including atomic bonding, composition, and properties. For example, you can see the picture here is the metals. Yeah, we can have usual metallic bond. Yeah, for the atomic bonding. They are also very well arranged, so it is called the crystalline. That's why they are strong, and they have a high melting temperature because of the arrangement or the relationship bonding of the atoms that we attach. Yeah, so they are very strong, so they have a very high melting temperature. Yeah, you need be about more than 500 or 600 to melt a metal. Yeah, and is usually used as dental alloys, which consisted of metal elements called gold alloys. Usually we combine gold with silver for others, or maybe also have cobalt chromium alloys, which we use for dental prosthesis. Yeah. All of these, the metals have a metallic bond, and it is the structure of crystalline. Yeah, very strong. Okay, the next one is the polymer. The group of materials that is polymer. Plastic. Yeah. And atomic bonding is with a covalent bond. Yeah, so it's let's call it, the structures is amorphous. Yeah, so because of their amorphous structures, they have the low melting temperature, lower strength than metals. They are more flexible. Yeah, and usually they like hydrocarbon, so hydrogen and oxygen and carbon, yeah, into giant molecular chain or networks. Yeah, for the example is rubber, plastic, protein, etc. Yeah, you have here the natural polymer. You also have natural polymer is like you have a rubber. Yeah, this is from plants. Yeah, is from bees or also from plants. Yeah, the polymer, and then you have synthetic polymer. For plastic bag, for packaging, yeah, plastic packaging, yeah, or bottles, yeah. And usually we have inorganic polymer and organic polymer. But usually the polymer is with organic polymer. Okay? Okay. Remember, the polymer have covalent bond. They are amorphous and they have low strength. Yeah, they are more flexible. Metal is not flexible. Yeah. Okay. One is ceramic. The ceramic has ionic bond. Yeah, you have 3 atomic bonding here. It's the metallic bond, covalent bond, and for ceramic is ionic bond. Yeah. This is ceramic crystal in inorganic materials. They have good strength, very hard. Usually, it means that if they got some what's call it trauma, or it is when you have a vase of porcelain and it just fell in the floor, then it will directly be shattered. Yeah, the properties of the ceramic is the porcelain is very brittle. Can you understand this? A ceramic, then you know it is like they are very brittle. They are very, very hard, but also brittle, and have a high melting temperature, and also can be used as insulator because they don't conduct the. I mean, they are not heat conductor. Yeah, so they are. For the example, is oxide, nitride, carbide, clay minerals like this. Yeah, clay that you will use for vase, for plates, yeah, to eat. And for in dentistry, we use it with the cement, glass, or porcelain, dental porcelains. Yeah, like this. And then the fourth group is usually the combination of 2 or more materials from metal, polymer, or ceramic. We combine these 2 or more materials, they have a new properties that is better than each of its constituent materials. Yeah. So the structure consisted of 2 phases. Yeah. So here you can see there is a matrix here and some maybe fiberglass. If you combine, which is very strong. Yeah, stronger. I mean, the composite is stronger than fiberglass or the matrix. Yeah. In dentistry, we use it as a composite resin for restorative materials for the teeth. Yeah, if you have caries and you would like to restore it, then you can use this dental restorative material like composite resin. Okay. What happened? Ini kenapa? Oke, sorry. Kenapa ini jadi tiba-tiba begini ya? Okay, next. So, from these groups of materials, is there any questions? Have to know the differences between all the groups of this material. So it is very different, yeah, from each other. Yeah, the metal, the and the composite. Okay. Okay, next is because you asked about the atom bonding, so this is a little sharing about the atomic bonding, but I think you already have or get this from got this from high school, yeah, and this is only to refresh your mind about the atomic bonding, yeah. As usual, it is usually in the metals. And this condition is a bond that is formed, yeah, in which the free electrons are shared among lattice cations. Yeah, so you can see here an arrangement of atoms like this. Yeah, like this. It's very ordered. Yeah. You can have heat. Yeah. It will also still be ordered, but a little bit of change. But they are going to still have the same order as before. Are malleable because they can be hammered into sheets. Yeah. If you hammer metals, then we can hammer it into sheets. So ductile because they can be drawn into wires. Yeah. So the mobile electrons surrounding positively charged nuclei make metals and heat. Yeah. As the number of delocalized electron increases, so does hardness and strength. Yeah. If metal is deformed, they still have the same arrangements or bonding between each atom. Okay. Okay, next is the covalent bond. This is a shared atom also, because like this, the covalent bond, it will be shared. The molecules will be more stable. Yeah. Electrons from both participating atoms are shared equally. Yeah. And it is also called the molecular bond. The sharing of the bonding pairs will ensure that the atoms achieve stability in their outer shell. Yeah. So here you can see they share the more stable, and it is usually in the polymers material. Yeah, the covalent bond. Next is the ionic bonding. Yeah, this is also the examples. When like the natrium or sodium chloride here, there is still one atom transfer, an electron here, one atom and transfer the electron to the fluoride, so they are more yeah. Okay, ion bond is the type of formed due to the electrostatic attraction between oppositely charged ions in a compound or molecules. So this one that loses that gain electrons is the anion. The sodium here lose electrons it's beyond. Okay. Okay. Now I would like to share a little bit about the relation of the metallic bond and the properties. Yeah. But here for the metals, they have properties of electrical conductivity. You know better about this, yeah? So the electrons in the electron C are free to move and carry charge. Yeah, that's why the metals with the metallic bond, they have the electrical conductivity. Also the thermal conductivity. Yeah, so the free electrons are able to transfer energy away from the heat source and vibration of the atom. Yeah, and then it will give the thermal conductivity. Is of ductility. Yeah. Usually, the bonds between the atoms can be easily broken and also reformed. The single atoms or entire sheets of them can slide past each other and reform bonds. That's why after ductility, the metal regain or reforms. Yeah, the the forms gain the forms again. Yeah. And also the properties of malleability, because there is a binding force between the metals, which is non-directional, and when drawing or shaping a metal is less likely to fracture it. Yeah. So we can use the malleability to form a sheet, yeah, or what's called it, yeah, lampang, yeah, something like that. It's very thin. Is the metal can be formed into a wire. Yeah. And also the properties of metal cluster. You know that from metals we can usually have the luster, yeah, because the electron C reflects photons off the smooth surface. But the condition, metallic cluster should be shape and very smooth, and then we give some polish material, so the condition of the metal can be very shiny, smooth, and it can have a luster, glossiness. Yeah. So the strong attraction between the atoms in the metallic bonds makes metal strong. They have high density high melting point, high boiling point, and low boiling. Yeah, this is all for the metals except for mercury. Yeah, this mercury is in the condition of a liquid and has vapor pressure. Okay, so all the metals in the zinc group, it is usually zinc, cadmium, or mercury. Very careful in using these metals. Yeah. So the properties of dental materials are divided into physical properties, mechanical properties, chemical properties, and biological properties. Yeah. These properties, I think you have already covered in your slides. Yeah, that's very good. But I hope that you will understand each of these properties, and it is you have to focus in studying this because it is not very easy and a bit of complicated, but in the big picture you have to know about this. Yeah, the physical properties is usually the optic properties, thermal, electrical, rheology, and others. Yeah. And the mechanical properties is usually the hardness, strength, the creep, yeah, about the materials. Chemical properties usually because of tarnish, aging. And the biological properties is about the toxicity, allergy, and the biocompatibility of a material. Yeah. Okay, for the mechanical properties, I think there is only one focus group that made this. Yeah, this one, stress and the strain curve. Yeah, this is the curve. So this diagram can give an information. Okay. Oh, there is the condition here. Yeah. Where there is the elastic deformation, and this one is plastic deformation. Yeah. So if you have a materials and you give stress, yeah, you give a loading in this material, and deform. Yeah, they resist, but they also deform like this. So when the stress is higher, will deform like this. Yeah. In this situation, this is the yield strength, yield point. In this situation, if you release the stress, yeah, the material, this is the elastic deformation, the material can to the condition, return to the early condition. Yeah, so there is no yeah, the deformation is only elastic until here. But if you give more stress, more loading, more force, yeah, and the material will continue to this. Yeah. Yeah, the maximum ultimate. And then if you still give more force or stress, because the properties of the materials, then it will go down like this. And then in some point, they will fracture here. See? So the yield point until they are fractured is called the plastic deformation here. This plastic deformation, there is already a deformation that is permanent. Yeah, it can go back to the condition that the early condition, like the elastic deformation. So in the elastic deformation, there is no deformation that is permanent. But in plastic deformation, from here to here, deformation that is permanent. Yeah. So the materials sometimes got change. Yeah. Maybe if a metal they have a necking. Yeah. And we can also see here from this the strain. Yeah, the strain is the change of length of the material. Yeah, here from when they are fractured, so the material is the length. Yeah. Okay, this is the Hooke law that we usually about the elastic modulicity, about the strength, the stress and the strain. Yeah. Okay, let's see in the other. Here, it's the same curve, stress and strain curves in mechanical testing. You can see here. Here, this is the elastic region. Yeah. And then the red here is the plastic region. So there is a permanent deformation here. Okay. So if you want to look better, you can find out in this YouTube. Yeah. Try to look at this so you can understand what is the stress and strain curve. Yeah. So this you usually use for testing dental materials on stress, modulus of elasticity, stress and strain, plastic deformation, and elastic deformation. Please, I think you have to read more about this, or you can also watch this YouTube. Okay? So, after you have already known the stress and strain curve, can you answer these questions? What are the properties of these materials? This red one, the A. What is the properties of this material? Can someone answer this?
Brittle, Prof?
Yes, this one is brittle because if you give load or force, it's getting higher, yeah, over here. But until this point, it just break here. Yeah, go down and break. Yeah. So this one, it looks like it is a brittle material. What about the B?
B is strong. No.
Yes, B is strong. So you hear the stress, when they give a stress higher, it, like this, but the strain is is higher than the A. Yeah, so this one is stronger. It is ductile, yeah, because the strain is very long, and also the stress is not very high. Yeah, it still have the properties of the force. Yeah, stress. They still have the resistance to from the strain or length here. So this one is a material that is ductile. Okay, next. So, very good answer. This is the comparison of the materials. I think you already have this. Yeah. So the difference between the metal, polymer, and ceramic. Yeah. The hardness is very. I think this is wrong. Yeah, for the hard medium, yeah. Polymer is very low. Yeah. Ceramic is very high. Elasticity, metal is high. It means they are rigid. Polymer is low, means they are very elastic. And ceramic very, very high means that they are very rigid. Yeah. And also there's properties here. Yeah. You can see here that the metal has no translucency. It also see only in polymers, which is very high, and ceramic, it is also very high. Okay. Okay, we now, I would like to give you a little bit about dental amalgam. Yeah, I think you explain about dental amalgams very good. Yeah. So just is a restorative material. Yeah, it is a restorative material, direct restorative material, which is alloy, silver alloy mixed with mercury. So remember, silver. So the keywords that you have to know is about the amalgamation on the setting reaction. And else they have the lead card, irregular or spherical or admix. And remember this, the gamma 2 phase is usually the compound that causes corrosion. It's usually tin and mercury here. Yeah, the gamma 2 phase. Because of the amalgamation, it will give a gamma 2 phase, which is very corrosive. Yeah, and then we have the high copper amalgam. It's less corrosive because we give a lot more of copper, which reduce the gamma 2 phase. And also the issue of from the Ministry of Health in Indonesia, they already gave some information that we are not using again the health devices which contain but in dental amalgam, face down means that there is no ban in using amalgam production. Have to increase the prevention of caries disease, so that the use of amalgam will be reduced. So the amalgam face down is only reducing the use of amalgam, not to ban, but because of that, we have to increase the prevention of caries disease. Okay. This is the composition. I think you already know about this. This is the lead cut. Irregular. And that's the combination of lead cut and spherical. The admixed particles. Okay. So you can see here about the conditions of the gamma 2 phase. To have the conventional alloys, amalgam alloys. So this is the low copper amalgam. This is the first amalgam and silver, tin, and mercury. The centering, this powder of silver tin and mercury, we just mixed it, and then there is when the reaction, it will show the gamma 1 and the gamma 2. Gamma 2 is the, and this one, gamma 2, is the most corrosive of the amalgam. So that's why the amalgam, usually they can corrode in the tooth, and then we should replace it again. There is a micro leakage and sometimes secondary caries because the gamma 2 is corroded. Okay, and then the development of amalgam, we use the high copper amalgam. So the copper is enriched in the alloys. We give more. Reactions still have this condition. It will cause the reduce of the will develop copper tin like this. So the gamma 2 phase was replaced with copper tin, and this copper tin and make the copper amalgam, high copper amalgam, stronger. It will not corrode, or maybe a little bit, but it is not corroded as. So you got it, this one? Because usually I ask this in the UTS. Okay, next. See, this one is very important. Here, so about tarnish or corrosion. So the tarnish is the oxidation that attacks the surface of amalgam, which is contact with the oxygen, chloride, sulfide, appearance like this. So usually it's very dark, it's not very beautiful, yeah. But the surface is still very intact. So it's only the discoloration from tarnish, yeah, it becomes darker. Corrosion by chemical or electrochemical reaction with substances in environment and negatively impacts the amalgam. See, you can see here, there is a break of the amalgam. It's usually corroded, yeah, because of the gamma 2 and breaks. Change of structure in corrosion. But in tarnish, there is no change in the structures, only the discoloration. Okay, yeah, you can see here there is a micro leakage over here because the amalgam is corroded. So if you have a good, very well finished and polished amalgam, this is the condition you give when we eat because of the chloride of the saliva and etc. It will sometimes be tarnished, and we can polish it again and it will be like this again. Yeah. That's why in the condition of the restoration, yeah, by visiting the dentist and make the amalgam polished, it will be like this. Okay.
Sorry,
Yes,
may I ask?
yes, please.
Yeah, for the amalgam, if it's already corroded, is it possible to fix it or polish it again?
Yeah, you have to replace it again. You have to take out this amalgam and then use another. If you want, you can use it amalgam, or you can replace it with composite resin. Yeah. If you have very bad amalgam restoration, then we can change or replace it with composite resin, or we can replace it inlay. This dental restoration or amalgam restoration is with a big caries, and they have a big cavity. Replace it with inlays, which is made from metals or porcelain, or we can replace it with. Okay, so but if it is still good, then we don't change it. Yeah.
Okay, thank you, Prof.
Okay. Next, this is the issues of amalgam. You know, because of the reducing of the health devices that contain blood pressure devices, fluorescent lamp, dental amalgam, batteries, or pharmaceuticals that contain it is not used anymore. It is from the World Health Organization, and the Ministry of Health also gave information to not use it. Yeah. And for the dental amalgam is not banned because there is the majority of the restoration before is made in use. And in this area, in Africa, they still use it. A lot of they still use the amalgam because the amalgam is very long-lasting restorative, but they are not aesthetic because the color is silver. But they last very long time, and it is very cost-effective for people in Africa. Yeah. But now we can replace the amalgam by composite resin, inlay or onlays or ceramic. And the issue of this amalgam is also highlighted in the Minamata Convention, yeah, from the World Health Organization. They have a meeting and they have a convention about the name of Minamata Convention. And these conventions controls and reductions across the range of products, processes, and in mercury. And the treaty also addresses the direct mining of mercury, export and import of the metal, and safe storage of the waste. And to use it, it should be stored in it's very isolated so that it cannot contaminate the environment. Yeah, will be banned by 2020. Yeah. Certain types of non-electric medical devices are also in 2020. Exception for some large measuring device where currently there are no mercury-free alternatives. Yeah. And the Minamata Convention calls for a phase down of dental filling using now dental amalgam with some dentists maybe in a remote area may still use it, yeah, because it is very and it longs with long-lasting materials, yeah, in the mouth. I still have mine for my teeth that it's already maybe 50 years, yeah, and it's still good. Yeah, but the WHO are saying that maybe if I died, yeah, I will be buried in the buried in the cemetery, then my dental amalgam will contaminate the soil. It's not very good. Or maybe if some people died and they have amalgam, and then the amalgam will be also be heated, and it will contaminate the air. Yeah, so that's why the use of dental amalgam should be reduced. Okay. Now, the last one is the dental cement. I think the classification explained, but there is no, I think, cavity varnish or cavity liners. Yeah, you have already explained resin-based cement, oil-based cement, but I think no cavity varnish or cavity liners. Yeah. So please, you look again about the composition, the setting reaction, because a little bit different from each cements, and how to manipulate the indication of the dissident. The properties is also different. I cannot explain you all of this because it will take a long time. Yeah, so learn it from the textbook. Yeah, this is a little bit from the best composition of dental cement. Yeah, so between the zinc oxide eugenol cement, phosphate, polysilate cement, glass ionomer cement, RMGIC is the resin modified glass ionomer, composite glass ionomer. Yeah, it's the combination between the glass ionomer and the composite resin, usually primary teeth, and the resin-based cement. Yeah, the resin plus silica filler, which is glass or silica, or the cementing like onlay, crown, yeah, bridge, yeah, which we can usually use it with or without. Okay. And this is the use. Yeah. Zinc oxide eugenol cement, usually for temporary or intermediate restoration of rooting agents, zinc phosphate also, and this is how we manipulate in eugenol cement. We usually use the mixing glass here or broader the glass mixing glass, so it is very easy to mix. Also the zinc phosphate, you can extend the mixing because the zinc phosphate cement is exothermic. Yeah, so if you mix it broader, heat will allow to vanish. Yeah, and this is the resin cement. Yeah, we just put it in the crown, and then we put the crown into the core of the tooth, and then we polymerization. This is the cavity varnish. Yeah. Use sometimes synthetic resin or rosin. We usually applied in the cavity. We all cavity. Yeah. And also to seal the dentin tubules and provide dental insulation. Use the post-operative sensitivity or discolorations. Yeah, usually the copal here, cavity varnish, is used for the dental amalgam restoration, because the dental amalgam, because of its metal, silver, mercury, sometimes they will of the dentin or the enamel. Yeah, so we use this cavity varnish. You cavity liners is only used to seal the dentin near the pulp. Yeah, they have a minimal this physical barrier with antibacterial or fluoride. Yeah, so they have a therapeutic effect. We applied only to dentin because dentin, you know, there is the dentin tubulis that have which will have a sensitivity. Yeah, so we do this barrier for so that it will have it reduce the post-operative sensitivity. Ionomer or calcium hydroxide. Yeah, see, this is the copalite varnish film. Here, sometimes we do the we use the calcium hydroxide liner, which is also an antibacterial materials. Yeah, that's why this cavity varnish or cavity liner we also use depending on the case. Yeah. There is a question about the types of glass ionomer. So I give you this classification books, in textbooks, in journals, and people give this classification. Sometimes it's confusing, but so that you all this classification. Firstly, this classification is only until type 6. First is type 1 is for luting, yeah, or liner or cement. Type 2 for restoration, yeah, usually restorative course, yeah. Type 2-1 and type 2-2. And type 3 is for liner or basis. Is fissure and fissure pit and fissure sealant. It's for preventive materials. Yeah. Type 5 for orthodontic cement. Only to bind the bracket into the enamel. Yeah. This is the type 5. And type 6 is the for core build up of tools that I mean the crown of the tooth is good shape. So we build up again to make a core of a tooth so that we can make a crown. Yeah. So after that, in the development of the GIC, the classification changed based on the application. Till type 9. Until type 6 is the same. And then we have type 7, the fluoride releasing light cured. Is usually because of the manufacturer or of GC. They develop the glass ionomer until type 9. Yeah. So type 7 is contain fluoride, and then type 8 is the GIC for a traumatic restorative treatment. It is a treatment in the poor people and remote area that have no dental facilities, so the cavity is only in it, and then we put this, we restore it with this type 8. Yeah, so it is called the attenuative restorative treatment. Yeah, and type 9 is GIC that it's used for pediatric, for children, and also for geriatric restoration, because usually children and old people, elderly people, they have a lot of saliva. Clean. They cannot clean their teeth properly. Yeah. This kind of GIC contain more fluoride for the prevention of caries or secondary caries. Okay. And this one, this third classification is the newer classification because of the development and technology of new materials. Yeah. First is the traditional glass ionomer, as you know, until type 3. It's the same with classification. And then there is the second generation, which contain glass ionomer with more. It calls the miracle mix. Yeah, it is the glass ionomer mixed with silver. Yeah, silver powder. So the color is all. There is the cermet cement. It means there is a combination between ceramic and metals for cement. This second generation now, I think it's not very well marketed now, and I don't need it anymore. And then we have the third generation, is the live pure glass ionomer. Yeah. Sometimes the glass ionomer, usually we use it as self-cure, but sometimes they put some photo initiator, ice, and resetting after light curing. Okay, and the fourth generation is the high. This is the hybrid and the resin modified glass ionomer. So the glass ionomer is combined with resin. Yeah, and it is more translucency, because usually glass ionomer has radio opaque condition. Yeah, but with resin, and the aesthetical condition is very nice, nicer. Yeah, and also the poly curing. So the setting time is more acceptable, yeah, quicker than the real glass ionomer. Okay. So if you are asked what is the classification, you can use this one. Yeah, until 6, type 6, and this one until type 6 is the same with this one. Yeah, this is from the textbook, Science of Dental Materials. Yeah, and this one is corporation, which is the manufacturer. They develop all kind of dental glass ionomer until type 9. And so the development, the traditional one, and then they develop with a metal, and then next to the. Okay, that's a long way. It is usually the glass ionomer is developed in the 70s. 50 years. So you know that there is a development and progress the technology of the. Okay, this is the question that you asked also about the agate spatula for glass ionomer cement. Yeah, why we use this one? Because this one is made of plastic and it is more flexible, and they have this yeah. Usually we use this one for GIC, yeah, and it is easy to clean, yeah. Sometimes we put in a glass of water, yeah, so that the glass ionomer will be released, yeah. And also you asked about the cement spatula and glass mixing slab. This is the glass mixing slab. Usually we use the thickness from 8 millimeter until 2 centimeter. But it's heavy. So now usually we use only the about 8 millimeters of. It is glass and it's very steady. So sometimes we use this glass and then we put the paper pad, yeah, for mix. See above this above this mixing slab, yeah, into the mixing slab, and it's made of stainless steel, double-ended like this one, and this is more and it is made of you can use it usually for cement, zinc oxide cement, zinc phosphide cement, yeah, but so use this agate spatula, yeah. The next radioactive material. I mean, there is no effect on the dental cement, but the effect is the appearance. Yeah, here you can see usually radiographic appearance of restorative material is radiopaque, yeah, or radiolucent, yeah. Dentin is radio-opaque and radiolucent, yeah. Pulp is radiolucent because it's organic. Amalgam is radiopaque, and dental cement here, like glass ionomer, cement, is radio-opaque, but it is not as opaque as gold amalgam. Yeah, it's lower than yeah. So I'm sorry I didn't get the pictures. So you can see from the radiograph of dental amalgam, cement, and composite resin, there is a difference of the radiopaque. They are radio-opaque so that we can see the condition of the what's called the restoration from the radiograph, yeah. Also to the resource person of Dr. Brahma, yeah, which will include also this one. So is there any questions? nearly 10 o'clock. Any question?
I guess it's clear enough, Prof.
So, do you have stop sharing. Do you have a class after this?
We have offline class, Prof, at 1 p.m.
Oh, okay. Not this morning.
No.
After this. Okay. I hope that you understand what I have explained to you. Maybe you all have covered in your slides, but maybe if I explain better for your understandings. But please, if you would like to ask me, just email me or ask me directly when we met, in the class, or anytime you want. Okay?
Okay, Prof.
Okay, Prof.
Okay? Enough. So to all of you is already here. 41, yeah? So thank you. And I hope to see you in the clarification of scenario 2. So when is the clarification of scenario 2?
Next week.
Next week on Wednesday.
Yes.
Same
Yes.
time.
Yes, Prof.
Okay. It apa sih, impression material, wax, and other one is what? Composite resin?
Is impression materials gypsum alloy
Oh,
casting?
gypsum. Yeah. Okay.
Yes. And wax.
Wax, yeah. I will see you in next week. But please, if you have some question, just ask me. Just into my clarifications, but please ask so that you will also learn it by chance. Yeah, so it will be more effective for you to learn, to study. Yeah?
Yes, Prof.
Okay. Oh. Today, now see you. I'll see you next week. Okay? Bye.
Bye. Thank you so much.
Thank you, Prof.
Thank you so much, Prof.
Okay.
Thanks, Prof.